So I will get started. I will trust that you can see my screen. I won't do the typical, can you see my screen here? So hey everyone, I hope everyone is doing well today. Thanks for joining us as we talk about ways to automate your security operations on the Azure WAF. My name is David Frazee, and I'm a product manager on the customer experience and engineering team for Azure Network Security. Joining me today is my colleague, Shabaz Shaik. So today we'll be focusing on automated detection and responses for SQL injection and cross-site scripting attacks for Azure WAF using Microsoft Sentinel. We wanted to showcase a technique teams could use to assist with attack response using a no-touch method when they're being targeted by malicious actors. So the solution we're showing will create a custom rule to block the bad actor's source IP outright on the Azure WAF. So, although the Azure WAF is successfully preventing the SQL injection and cross-site scripting attacks, we want to avoid the attacker from having an opportunity for further reconnaissance or to consume resources of the Azure WAF engine. So this technique can be applied to the Azure WAF on front door or application gateway. So for today's agenda, we'll do an overview of what the Azure WAF is, showcasing features and capabilities. We'll then very quickly touch on Microsoft Sentinel and its SIEM and SOAR capabilities. Then I'll go over the actual technique and show key points for configuration. And then lastly, we'll end with a demonstration from Shabaz and answer any questions that there may be. All right, so let's get started with Azure WAF and talk about some common attack types. So there are quite a few different attack types we see commonly hit web applications. We see DDoS attacks at layer 3, layer 4, and layer 7. We see malicious bot attacks where bots are used to scrape data, scan, and look for vulnerabilities. But today we're going to focus on web application specific attacks. So these attacks comprise of SQL injections, cross-site scripting, remote file inclusions, and more. Pretty much in short, the OWASP top 10. So injections do account for a large volume of attacks seen against web applications, with most public-facing web applications being tested against some form of injection throughout its lifecycle. So since SQL injections and cross-site scripting attacks are so prevalent, we place emphasis on these attack types for this mitigation technique. So let's just get ourselves familiarized with the Azure WAF to better understand the technique we're discussing today. So the Azure WAF is a layer 7 firewall that provides centralized protection of your web applications, both internal and external facing, from common vulnerabilities. These applications, they can be in Azure, on-premises, or even another cloud provider. When enabled with services such as Azure DDoS protection and Azure Firewall, the Azure WAF can be used to implement a zero trust network security architecture in the Azure cloud. So the WAF can be enabled either on the global edge when you're using the Azure front door, or at a regional level when you're using the Azure application gateway. It is platform managed, allowing teams to focus on custom rule creation and exclusions when needed. Managed rule sets are already predefined for OWASP top 10 protection, bot protection, and more with the introduction of the Microsoft proprietary Microsoft Threat Intelligence Center rules, or MYSTIC rules. It quickly responds to new attacks that are identified by publishing new rules in the known CVE rule groups for both front door and application gateway. If an already existing rule does not block, let's say, a new attack by default. We also use the MYSTIC rules that we just mentioned to prevent any type of zero-day type attacks. Azure WAF also has a custom rules engine. So these custom rules allow you to create your own rules that are evaluated for each request that passes through the WAF. You can define your own rules based on geo-filtering, IP restriction, HTTP parameter filtering, and size restriction. So today we'll be using a mix of both managed rules and custom rules to block and prevent malicious actors from exploiting our application. The Azure WAF also has DevOps integration, ARM templates, REST API, PowerShell, CLI, Terraform. These are all methods that you can use to easily build, deploy, and manage the Azure WAF. Our playbook that is integrated with Microsoft Sentinel is using the Azure WAF REST API calls to automate this custom rule block once the injection incident is created. And lastly, the WAF provides metrics and logs through Azure Monitor that will assist in your incident investigation. So these can be ingested by Microsoft Sentinel or another third-party SIEM. Okay, so now let's talk a bit about Microsoft Sentinel. But before we get into the next slide, I'll preface this with saying myself and Shabaz, and then some of my teammates who are also helping with the questions here today, we're not technically the Sentinel experts. So if you have some Sentinel specific questions, I would say to leave that for another public webinar that is specific around that. We are more in the NetSec or network security realm. But if you still have the feel to ask the question, then go ahead. But just wanted to just be mindful. We might not be able to answer all the Sentinel questions, but feel free to ask away about Azure WAF. All right, so Microsoft Sentinel is a scalable cloud-native solution that provides security information and event management and security orchestration and automation and response capabilities, so SIEM and SOAR. So Sentinel delivers intelligent security analytics and threat intelligence across the enterprise. And with Sentinel, you'll get a single solution for attack detection, threat visibility, proactive hunting, and threat response. Data connectors allow Sentinel to ingest data from a wide variety of resources across the enterprise, especially with Azure first-party resources like Azure WAF, Azure Firewall, and Azure DDoS protection. So query language, or KQL, is the language you use to work with and manipulate data in Microsoft Sentinel. The logs that are fed into the workspace will be of little value if you can't analyze them and get the important information hidden within the data. If you have a background in scripting or working with databases like SQL or even Splunk, KQL will feel very familiar to you. If not, don't worry. The language is intuitive in nature and will quickly enable you to start writing your own queries and really driving value for the organization. So Sentinel gives you a few different ways to use threat intelligence feeds to enhance your security analyst ability to detect and prioritize known threats as well. There are built-in threat detection rules available out of the box to use. Rule templates were designed by Microsoft's team of security experts and analysts based on known threats, common attack vectors, and suspicious activity escalation chains. Rules created from these templates will automatically search across your environment for any activity that looks suspicious. And many of the templates can be customized to search for activities according to your needs. The alerts generated by these rules, they will create incidents that you can assign and investigate in your environment. One of Sentinel's primary purpose is to automate any recurring and predictable enrichment response, right? And remediation tasks that are the responsibility of your SOC team. This is pretty much freeing up the time and resources for a more in-depth investigation for more advanced threats. Automation takes a few different forms in Microsoft Sentinel, from automation rules that centrally manage the automation of incident handling and response, to playbooks that run predetermined sequences of actions to provide powerful and flexible advanced automation to your threat response tasks. So this comprehensive solution is built to support next-gen security operations, and it delivers integrated investigation and response capabilities across different security layers. All right, so now we're going to start talking about the method to automate detection and response for Azure WAF using Microsoft Sentinel. So to put the technique into perspective, I'll cover what happens once it's enabled in the environment. So first, a malicious actor will send a request to the web application with a SQL injection or cross-site scripting attack embedded. The Azure WAF will identify and block this malicious request, preventing it from getting to the backend application. Next, the Azure WAF will generate a log based off the block and send this to a log analytics workspace. The logs created in the log analytics workspace will then be ingested by Microsoft Sentinel. Once the log has been ingested by Sentinel, the analytic rule that is activated within the workspace will trigger an incident for future investigation and case management. This incident, though, it will trigger an automation rule that is tied to the activated analytic rule executing a playbook. This playbook then makes a REST API call against the Azure WAF and either creates a new custom rule if one doesn't exist, or updates an existing custom rule with the malicious actor's public IP configured in the match variables. And to just to kind of answer this question, if anyone has this in mind, if you have multiple attackers, all the different IPs will be assigned to the match variables as well. So this is not just for one. It's not one custom rule per attacker. It is one custom rule for all attackers that will hit this incident. This custom rule will block any further attempts from the malicious actor's public IP up front, rather than being processed through the entire WAF managed rule set. All right, so now we'll talk about the steps for configurations. The first thing we'll need to do is deploy the Sentinel playbook that you can find in our GitHub repository. When you deploy the playbook, you'll need to provide some parameters that are necessary for it to work. You'll pass on the front door resource ID or the application resource ID or both if you are using both in your environment. You'll also have to provide an Azure AD or Azure Active Directory user ID to be part of this solution. Once the playbook has deployed, you'll see a logic app deployed into the resource group as well as an API connection resource. You'll need to open the API connection resource in Azure and authorize the API. There will be just a simple button to click to authorize, and that step is complete. Next, you'll assign contributor rights for the logic app to the Azure WAF and front door or application gateway that the WAF policy is assigned to. Once the playbook has been deployed and the proper permissions have been assigned, we'll configure and enable the analytic rule in Microsoft Sentinel. In the Sentinel workspace, you'll navigate to Analytics, and in the Rule Templates tab, you can search for WAF to find the built-in WAF analytic rules that are available. There is a single SQL injection rule and cross-site scripting rule for both front door and application gateway. So 4 in total, one SQL, one cross-site scripting for app gateway, and then the same for front door. You'll need to enable these separately when you're going through. You won't be able to, at least from the portal, do a bulk activation of all 4 rule templates. Once you select a rule to start configuring, you'll have to set sections like query scheduling and alert threshold that will match your environment needs. The query logic can also be manipulated and changed to match your environment needs if that's necessary. But the query logic is written in KQL or so query language. So if you are comfortable with that, then you do have the ability to make adjustments to these templates if that's absolutely necessary. In the incident settings, you can configure alert grouping to aggregate incidents if your environment sees a large amount of these specific types of attack on average. Finally, we'll configure the automation rule, which will define our trigger. So in the automation response section of the analytic rule activation, select add new for automation rule. You'll need to define the trigger to be when alert is created and not the default action of when incident is created. For actions, you'll need to select run playbook and then select the playbook deployed earlier from the drop-down menu. If you don't see your playbook in the drop-down menu, which this does happen, you'll have to give Sentinel permissions to your resource group. If that is the case, select Manage Playbook Permissions under Actions in the blade and select the resource group where the playbook is deployed. This will fix that error without issue. After this, you'll be finished with the configuration of the analytic rule. You can repeat the steps for the second analytic rule that covers either the cross-site scripting attack or the SQL injection attack. If you're already using these analytic rules in your environment without the automation rules, it's really simple to configure after the fact. You'll just follow the steps for deploying the playbook so that you can run it as an action against the rule. Then instead of creating everything through the Analytics tab in Sentinel, you'll go to the Automation tab in Sentinel instead. From the Automation tab, select Create and choose Automation Rule from the drop-down menu. Provide a name, select when alert is created, and then in Conditions, under the Analytic Rule name, you'll just select all of the appropriate analytic rules and click Create. Once that's done, you'll pretty much have this entire technique activated within your Azure environment. So that was it for our configurations and overview. So now I'll hand it over to Shabaz for the demonstration.
Hey, thank you, David, for walking us through the scenario and background. Let me share my screen here. I hope my screen is visible.
Yes, it is.
Okay, thank you. Hello, everyone. This is Shabaz. I will be taking over and going through the demo scenario here. So basically, David covered it really well about what we're doing here and how we'll be, tackling an attack with an automated detection and response from Sentinel. So I want to walk you through some of the resources that we have deployed for this particular demo. So this is the resource group where we have deployed the required resources. The important ones that we need to look at are the playbook that David was talking about, which is the logic app here, and the API connection that he mentioned during the configuration. And basically, we have a app service that is hosting our website, which we are using for this demo purpose. And this app is basically being protected by WAF behind the front door, which is AFD WAF tag. This is the front door resource we have. And this app service sits behind this front door resource. And let's take a look at this front door resource. So this is the front door resource we have. And as we can see, this is the endpoint that is behind this front door. And we also have a security policy, that is the WAF policy attached to this front door. So this security policy will basically be protecting this endpoint from any malicious attacks. And let's also take a look at the security policy we have, which is listed here. Let me go to this next tab. So this is the security policy. We haven't configured anything here. This is, by default in prevention mode, and we haven't changed anything on the managed rules. But if we take a look at the custom rules section here, as we can see, there are currently no custom rules configured. So the idea here is once we run an attack to the web app, what we will be having is Sentinel will be detecting it and responding to that attack with the help of the playbook and creating a custom rule here in this section. So in order to do this attack, we have a client machine. If we look here, the public IP address of the client machine is 1367.187.220. So let me try and log into this machine, which I've already logged on right now. And let me open a web browser from this particular machine and go to this particular URL, which is sitting behind AFD. This is the sample website we have. So as we can see from this endpoint, we are clearly able to go to this website without any issues as of now. Now, in order to run an attack, I'll be using a Postman profile. So basically, this will help us, simulate a WAF attack very easily. We have pre-configured profiles here for SQL injection, cross-site scripting, and everything. We have predefined information on what we will be sending in that post and get request to that website. So let's go ahead and run this collection of attacks. So we can easily run this by just, clicking on run collection. If you don't have a Postman profile, you can manually do it as well. Just for the sake of this demo, we have predefined profiles here that will, easily give us the ability to test it here. So I'm running this attack with probably just like, 4 iterations. So it will give us the details on all the iterations, and the attack has been completed. So in 4 iterations. So now let me go back to the Azure portal. And if we look at the Sentinel blade, if we look at the incidents, this is where we should be getting an incident for this. So right now, if I refresh it, there are no incidents. So let's give it a couple of moments for this incident to be populated. Meanwhile, we can look at other details on Sentinel Blade. So if we scroll down here, so this is the place where we have the analytics section. And in the analytics section, we have configured a few analytic rules that David was talking about. So we have rules for SQLi detection for front door and XSS detection, as well as SQLi and XSS detection for app gateway as well. But in this scenario here, we are using front door WAF to demonstrate this particular detection and response. So let's take a look at one of these analytic rules. When we click on edit here, it will give us detailed information on what kind of query that is being used. So if we want, we can edit this query depending upon the needs of the infrastructure. And we can also change the scheduling of this query and event grouping and everything here. If we go to the incident settings section, we also have some incident groupings and different parameters that we can change. And finally, the most important part here is the automated response section, where what happens is whenever an incident gets generated through an alert, so this particular automation rule will be triggered. So let's look at this automation rule as well. So I'm clicking on edit here. So when we take a look at this automation rule, so basically this is having a trigger which says when alert is created. And basically the action here is it will run the block IP Azure WAF playbook, which we have deployed in our resource group, which I was talking about. So this is the logic app that I was mentioning at the beginning, and that is the playbook that we're talking about here. So this is what the playbook looks like. Basically, this is a set of inputs and commands in a chronological fashion. Once we give all these inputs are given during the deployment, and finally, this playbook will create custom rule on the WAF policy. So let me go back to this automation rule. So as we can see, once the alert is created, this playbook is triggered, and then we should see a custom rule created on the WAF policy. So that's how it's going to work. So let's go back to our Sentinel Blade and see if we have any incidents created there. So let me scroll up, and this is the incident section. There we go. We have a couple of incidents created, and one for SQLi and XSS detection, since we ran both the attacks as a collection from the Postman profile. So as per the theory that we were mentioning, what it should be doing is once this incident is created, the playbook should have already created the custom rule on the WAF policy. So let's go ahead and take a look at the WAF policy that we have. So this is the policy we have. And previously we didn't have anything here, no custom rule. So I'm refreshing it. There you go. So we have a custom rule created as part of this particular automated detection response. So let's take a look at this custom rule. So this custom rule is basically blocking everything from source IP 1367.187.220, which is our client machine that we use to attack this particular web application. So pretty straightforward here. So if you want detailed information on how to configure this particular flow, all the analytic rules and the automation rules and everything, we have a detailed blog on this particular topic as well in our security tech community. Please go ahead and take a look at it, and you can set this environment yourself for your particular web apps. Let me go to the attacker machine again, and let's try to go to the same website once more from here. So it should have been blocked, but for some reason it's coming up. I think the custom rule hasn't taken effect yet, but let's give it some time. But that is the gist of it. And that's how we can do an automated detection response with Sentinel for Azure WAF. So basically, by doing this, we can block subsequent attacks from this attacker IP, even for legitimate traffic. If something is legitimate, even from the source IP, we will still be able to block it because it tried to attack in the past. So that's about it for the demo. We can move on to the questions section.
Yeah, thanks, Shabaz. And really to just kind of talk about, you went to the OWASP site again, but really, I believe the issue was Microsoft Edge just really does have a lot of caching that's enabled. Maybe if you were to open in private browsing, we would see that block there.
Yeah.
Great. The team has been really on top of answering the questions. We do have a couple here that might be worth reiterating. The first is, when I receive an incident for WAF front door and the action item shows blocked, how do I determine this is a false positive? Should all be blocked? Should all blocked be excluded or suppressed?
Okay, so a flow comes into the Azure WAF and they're seeing within the logs that there is a block. How do I determine if this is a false positive? Really, when we're trying to determine what's a false positive and what's not, whenever you first deploy the Azure WAF, whether it's going to be for application gateway or the front door, we recommend that there is a tuning period of at least 2 to 3 weeks when you first deploy this, right? And so you're in a detection mode, and then all traffic is getting thrown to your backend through the WAF. At this time, you'll be able to actually see every hit that each flow would hit against on the managed rule sets, custom rules, or maybe even the bot manager rule set. From there, there is where you'll really determine where your false positives are at. So you'll see like, oh, hey, that was a legitimate flow. I see that it hit a lot of SQL injection managed rule sets. We'll have to create an exclusion for that because that is a false positive. But really, that is just when you're trying to determine what a false positive is. You should really be doing that during your tuning period when you first deploy the Azure WAF in your environment, and then just running through your tests just to determine what is a good flow and what is a bad flow.
Great, thank you. The next question we have is front door or WAF, which is the ideal product to face internet, such as untrusted networks?
Right, so front door is really like a CDN type capability resource, and WAF is your protective resource on top of the front door. So the front door and application gateway, these are going to be internet facing resources. They're application delivery platforms. The WAF is just an additional resource that is attached and tied to the front door and application gateway for that application protection.
Great, thank you. The next question is, will a different rule be created for each IP that is detected, or will new IPs be added to the existing rule?
Yep, exactly. So new IPs will be added to the existing rule. So if you have this solution in place and there is not an already existing rule, a new rule will be created, but it's only the first time. And then anything after that, the IPs will just be assigned to the match values of that custom rule, but only one custom rule will be created.
Great, thank you. The next question is that runbook or playbook, will it work for WAF in detection mode?
Actually, I'm not sure. No, actually, you'll have.
I can take that one.
Okay,
Yeah,
Shabaz.
I can take that one. So basically, how the detection works is we have a similar set of logs that we need to match for that query. So if in the detection mode, we won't have any block logs, right? So in that case, the detection won't retrieve any data at that point of time. So we need to have the WAF in prevention mode for us to make use of this scenario and the playbook.
Great, thank you. The next question is there any material for mitigating the false positive?
Yeah, I do think Toby from our team actually just released a great blog that talked about false positives in our tech community. So I know that I think there was some links shared to our tech community. If you go through there, you'll be able to find there should be a false positive or WAF tuning blog written by our team that should cover or at least help with the tuning process.
Great. Well, that seems to be all the questions we have. So I'd like to thank you, David and Shabaz, for being our guests today and for an excellent presentation. And thank you to the rest of the team who helped answer questions. At the same time, I would like to remind the listeners that the best way to ensure you don't miss any future webinars or major announcements is to visit our landing page at aka.ms/securitycommunity. And while there, you'll find easy ways to navigate and find the resources and learning content relevant to our security products and their communities. A good start would be browsing our bite-sized product videos, ninja trainings, recordings of past webinars, GitHub communities, and more. We'd love to hear your feedback on how we can improve these webinars. Please take a minute submitting your webinar feedback at aka.ms/Azure NetSec feedback. Thank you and see you next time. Goodbye.